Bedini style coil, 30 gauge, 26 gauge, wound on top of each other for 999.9 turns.
Wow.
Yeah, we might have to do that again, but that's okay. Because I got a core in this bad boy too. It's a nice one.
Nice.
So as soon as I learn how to hook it up right, we're going to test it out. Probably on the white rotor, I think. We're going to do it right there. Oh, no, wait a minute. We can try the aluminum rotor.
Mm.
I'll bring them both over there. Let's get some action.
What's up, BLS?
What's up, my man? BLS. My fault. Alright, we're going to test out this Bedini coil. Do you know how to hook up Bedini coils? The Bifilar coil, I should say. And it's 30 and 26 gauge. And I just wanted to know how I hook that up. Get this out of here. Get it out! Get it out again. Alright, there we go. Okay, it's gone. Well, that's stuck.
You got some glue spot. Oh, you got a whole thing. You need a mallet.
I don't know what I need. I might need pliers.
Pliers. Here we go. Needle nose.
I think the real pliers are right. No, maybe not.
I'll keep an eye out.
Either underneath that case on top of the. Yeah, that. The screwdrivers in it. Got it. Never mind.
Nice.
Right. I can just figure out where to put the coil down. Here it is. Alright. I only need a stand for it. We printed these out. So the beginning of the coil will face outward. Actually, I don't want to do it like that. This. No, I'm trying to get it in the middle and it's not going. I need pieces that I have. Try that. Is that gonna work? Yeah, that's close enough, right? It's towards the top, but
Yeah. Yeah. So it's just under the rotor.
what's it? Look at that traction. It's just light enough. Okay. So maybe we just prop it up like this and mount it like this. That'll be perfect.
Yeah. Hey everybody, welcome to the channel.
Hey, what's up? Hey, we're hooking up a bifilar coil right now and testing it out. I got a 30 gauge and a 26 gauge wrapped on top of one another. So I'm thinking the power goes in the small one, in the 30 gauge, and then it goes through and then diode to the 26. Would that be right? Sounds right to me. Let's give it a shot.
Right.
We need to definitely tether this down a little bit. I wonder what's going to happen. I really do. I mean, it's a great coil. It's 999.9 turns. So we're utilizing 6 and 9 so far. This one's made out of everything 6. Make sure that that is all good. Yeah, that's good. Let's turn that on real quick. See if it's still good.
Nice.
Oh yeah, that's nice. We're gonna run this off a reed switch. Yeah, that's good. Oh, I gotta get some glue for the base. Finally, use littler amounts of glue.
Just it still works just as good.
Yeah. I'm just going to press that down for a few seconds. That should be good. Alright, so we're actually going to go into the reed switch first. And then we're going to go the reed switch into that's it. And then we need a diode. It's a rectifier diode, 1000 volts, 3 amps. And we're going to hook it up to go DC back into 26 gauge coil. Now, is there anything that I'm missing? Please let me know if there's anything that I need to do other than what I'm doing. Or if I'm doing it backwards, that'd be good to know too. This one. Alright. Now, I'm going to turn the power on.
Like the sound of that.
Hell, that would be awesome.
Hey everybody, welcome to the channel.
Hey, what's up? What's up?
Drop a like, subscribe, leave a comment. We are setting up.
Now, I got ideas on how to hook that up, but I'm just going to hook it up regularly.
It's been Bedini-style, Bifilar, coil. Is that an iron core?
Yeah.
It's an iron core.
Yeah, I need, since I'm reverse engineering this from cannibalizing as I go kind of thing.
Right.
I need actually a bigger connector right now. I'll just use the screen one. Because I was doing a lot of experiments on this side.
Yeah.
I already got connections to the power supply all ready to go.
You need that on there?
Yeah,
This one?
I think so.
Let's see if I can do. Let's see if I can film this.
Yeah, that's power in, red. Yep, that's the one I need. Okay.
Oh, I didn't quite film it, but I got it.
Good job. Alright, power in, good. And then we need power out. That was the power out.
Okay, got it.
So I need to take this one, this was the power in, and put it in the power out.
That's right here.
Yeah.
Okay.
Do it?
Yeah. Actually, here, let me do it like this.
It's difficult, isn't it? Well,
It-
when you first try it, you gotta get used to the tension.
Yeah, they're pretty. Okay.
Yeah, we're really tight. Okay. So, and then we put that ground to the ground. And get this 4-filer coil out of here. Alright. Yeah. Let's see what we get. Start like that. Pigs, what you doing? This switch isn't lighting up. So I got another idea. This might work though. I mean, it still might be working, but the indicator light is broken.
How's it going, Bedram?
How's it going? Heck yeah, here we go. Switch, gold plated switch. We're gonna go gold plated.
Gold plated switch.
Now, with the gyro, I just glued the switch like kind of right onto the coil. I'm gonna try the same thing with this. Now there's a lot more power coursing through this coil than probably all those coils put together. I mean like amp wise, definitely.
How's it going, Mike?
Hey, what's up? Power off. Here we go.
Oh, nice. I got it. Oh. My dad loved that show. Paka!
Alright. I'm gonna get it its own. Well, actually, we don't need to do that. We're gonna put it right there. Here, give it a little juice. No, just a little bit. Tiny bit. Alright, we're arcing.
3.
And 3.
Oh, yeah, look at this, guys.
Yes, no, wrong way. Do it the other way. Yeah.
Oh, wow.
Uh-oh.
Oops, I'm in the way.
No, I think it's blown. My bad.
Oh, so that was,
Gotta get it on its own stand.
got it.
No, the arcing was good. It means it was working.
Yeah.
I just probably put it too close to these powerful ass magnets, or the coil blew it out because it needs to be in series with other coils like itself
Yeah.
for increased resistance. The coil's got enough resistance if you put the right ones together in series.
What's up, Peter?
Hey, what's up? Did you turn that down?
This?
No, power.
Sorry.
Yeah, not bad. And that was 34.
I got it.
Yeah, my bad.
Yeah, you should do that.
Well, all right. We can change it up.
Oh, no, I'll do it. So make
We
sure
can
it's,
change it up to the other power supply.
but well, no, I just got to realize how touchy this one is. So let me try that again, actually. 3, you only need 2.
Let's just put it on 12
Okay.
real quick.
There we go. 11.2?
Yeah, that'll work.
Okay. This way?
Yep. Wow. It might be too much for the reed switch.
Because it was way up on the last one. Maybe more or less. Or
A
do you
little
think?
more, try a little more.
Okay. Let me get out of this. 17, 18.
Yeah, no, it's
Okay.
blown already.
Okay.
Wow. It works better with the less powerful coils. Could you turn it down?
Yep.
All right.
Hey everybody, welcome to the channel.
It gets going and then it's like it's too much. So I'm thinking I need to put more of these coils on there for it to work better. I could try a Hall effect, and there's lots of things we could do with this. But it is hooked up correctly. That much I do know.
Put a 50 OHM on the reed. I don't know.
I don't have any OHMs
Okay.
available right now. I have one 200 ohm at the ready.
Or a potentiometer.
That might be one right there.
Oh yeah, right there. That's a pot.
Yeah. Alright, let's see. We tried hooking up one of these before, because it's got to have all this DC crap and everything, and it blew up the first time I used it.
So we'll dedicate some time to learn, we'll get a whole packet of stuff.
Yeah, I'll figure it out.
Yeah, you got this. Look at all the stuff you pulled out already. Wow.
Oh man, man, if it could be AC, it'd be really easy to hook up. But yeah, he's right. Whoever mentioned the resistor thing, I don't have a 50 ohm resistor though. Maybe. Maybe I do. What's this one? 1K ohms.
Oh, 1K, that's what you got.
But it's 1/4 watt, 1% tolerance. We could try it. So power into resistor,
Is it-
resistor into,
He said definitely try it. Might not get anything, but definitely try it.
yeah, worth a shot. I need another clip. Got it. Alright, resistor is hooked up.
Limit the current. Okay. Yeah, you might want to change the power input.
The power supply.
Yeah.
I will.
Okay.
We're gonna do this one more time because that's a labor intensive thing.
Oh, okay.
You know,
So
no, it's
just
not
keep
really
it,
bad.
keep it below 10.
Yeah.
Okay. All right, here we go. I'm gonna start at 5. Oh, 7.5. And this way. There's definitely some movement.
How hard did you push it?
Not hard.
No, I didn't want you to push it harder.
Oh, my bad.
Here, let's stop it and see what happens. Yeah, it's not working.
Okay. Yeah, let me get that.
It's
All right.
too much, too many ohms there. So we're gonna switch the power supply out. But I want to check this out real quick, see if we can get it. 7.5.
$7.19. The only thing limiting amps is the loading coil, aka the drive. There was a lot coming in. Hey everybody, welcome to the channel.
Hey, what's up? We're struggling with this coil right here. I don't know.
If read amp rating is below the load coil draw, it will blow. It's definitely working.
It's working. Turn it up a little bit.
12.
Yeah, that's good.
I see it. I saw an arc.
Oh, maybe that was it blowing out. There it goes.
There it is.
Ah, it doesn't work upside down? What the hell?
Oh, it's directional?
No, it's not. It can't be.
Oh, okay.
Maybe it can. I don't know. You know what? I think it's that DC diode in there is screwing it up.
Mike's having a good time.
Awesome.
Good. Read position is sensitive. Yep. Ooh. And I zoomed in right when that happened. Sorry, folks. A clip got a magnet.
there's something else I did want to try, and that's the aluminum rotor that I got. Because not my next one, but my big build is going to be just that style of drive. It's not going to have any coils. I mean, neodymium magnets in it.
Hey everybody, welcome to the channel. Drop a like, subscribe, leave a comment. Let us know if you're passionate about magnets.
Alright, I wonder, what about a Hall effect sensor and a transistor? I got one right there.
That I know that Peter recommended that.
Alright,
He said a big juicy transistor.
Got these insulated gate ones. You know what? I'm going to use a fresh one. They're a little bit smaller, but they're the same speed identification. So they're fast switching, but they're for a breadboard, a regular breadboard. Alright, I need my the packaging is so good that it took me a month to get in. Alright.
That's the excitement of our unboxing.
Oh, look at these. Alright, so I had a theory though. If you needed to like power what was going on, you need to have everything be able to be placed on the rotor itself. Balanced, of course. You get your battery, you get your chipset, all on the rotor. And that's one way of doing it. I'm sure there are other ways. Alright. So it's not hooked up right now. Hook it up. Right here.
Oh, we figure this out.
The base. Yeah, go ahead, please. Thank you. The base. And that's got a hook to the base connection of the reed switch. Oh, there is a connect on it already. I didn't see that. Okay. So we'll save this for later. Over here, because I'm sure we're going to need it. There's so much like ampage going through that coil because it starts off with 30 gauge, so the resistance is high, and then it lets go of the resistance, and it flows to a 26 gauge. Man, it's hot. That's what I'm gonna say. And both of them are pretty high amp, in my opinion, because I'm used to working with 32, 36, 34. And then I did some work with some fat stuff too. 16 gauge coils, man, they're dope. Dope. Alright, so collector. Probably should get a breadboard out. Oops.
Thanks, Mike. We'll check it out.
Hell yeah, man. That's what I was looking into, like signal generator stuff to run the aluminum rotor. Okay, so now we need to ground it. Um, yeah. It's coming very close, but it'll work. Alright. Do I have everything I need? Is it all set up? Ah. Power. Which one? I think it's going to be this one, because that's the one that got wrapped around. Yeah, that's it. Alright, let me get the whole quick sensor. And so we're going to see exactly how much we need to, if it's still working. I mean, it should be working. Who knows, right?
Mike asks, can you talk about the UFO double rotor one?
Oh, you want, okay, yeah, that's,
What's the ambition?
oh, the ambition. I saw a picture and I wanted to see if I could do it, and I wanted to see what a gyroscope was all about. It pretty much does everything by itself once you turn it on. Actually, all I had to do is get the right resistance on the commutator, and because it's got to stay on all the time, because I do a reed switch. Yeah, there are 1,111 turns in each one of those coils. It's 32 gauge, and so there's 6 magnets in the rotor, and there's 6,666 turns of copper in the apparatus. There's, let me see here. No, that's pretty much all the 6s, but that's pretty much everything that it is right there. So.
Have you done any measurements on it?
No, I'm not tethering it. It won't work tethered.
Okay.
It won't work tethered. I can't measure it. That's what I was thinking about the other day. How am I going to measure this? You can't measure that. Unless you got like an infrared measuring tool, you know. Oh, you mean when it's not moving? Ha ha ha! My bad, dude. I thought you meant when it was on. Yeah, I should do that. I wanted to test the ohms and I totally forgot about that, man.
And then duty cycle.
Yeah, how do you test the duty cycle? Is that with the oscilloscope? I got a multimeter that's not an oscilloscope somewhere. And that's right there. And another one somewhere. Before I even put it away there.
Duty cycle is how long the commutator makes contact. So we got a
95%.
okay.
95%. It has to remain in contact pretty much to run everything. Yeah, it's up to 63 volts when we turn it on all the way. That's why we're working on upping the power in our coils a little bit so that we don't have to turn it up so high. Yeah, man, there's to run a reed switch. I don't know. Can we commutate it and actually use it as a switch? I don't know. Well, it does, man. I mean, it 36 volts and however many amps it's taking. So, I mean, 63 volts. My apologies. 63 volts. All right, we're doing this. This is good to go. Let's turn it on. Low though, like start at 5. See if this turns on. Yes, good.
The tighter the ohms, the more volts, or the higher the ohms. Excuse me.
Yeah, it's got to have quite a few ohms. I know that the 22,000 turn coil has 420 ohms in it. I don't know where to put this. It's bugging me.
Oh, 1.5 watt. All right.
Hey, at 1.5 watt. Use 1.5 watts. Yeah, we don't know what the. Turn it up a little bit. Like to 12. Alright, let's get it. I don't get it. With my little dinky transistor that I pulled out of there. We're gonna have to do a trigger coil. I'm sure that'll work. Alright, let's cut the power. This is it, man. We're gonna get this.
Hey everybody, welcome to the channel.
Believe in making a super trigger coil
Ooh.
that has a core in it? No, I'm kidding. It's gonna blow. I mean, I've thought about trying that. Does anybody think I should try that? I think he's gonna blow out the transistor like immediately. You know what? This one isn't hooked up right now. So I'll just move this one over there.
Hey everybody, welcome to the channel.
Hey, what's up?
Thank you for stopping by tonight. Drop a like, leave a comment. Let us know if you're curious about pulse motors, coils, electromagnetism, magnets.
Perfect. Alright, I need some glue. Got this. And there's the resistor I was going to use right there. Mm. So I don't think there's enough coil here for a Hall effect sensor to, I don't know if that's right, but that's what it feels like. But this should work without a problem. We gotta take. Because usually when the Hall effect sensor is working efficiently, it's got a pulse along with its static light. So there's a light that's always on, and there's a light that pulses. In these anyway, there's an indicator light that shows that it's working. I didn't see that going on. Okay, I need the diode. Oh, right down here. Diode. There it is. See, when you put everything away, you try to leave out just what you're going to need, and sometimes
Can't find it.
yeah. Another one.
Clip.
Yeah.
I got one.
Thank you. So I usually we start with the start. So it starts in the center of the coil. If you have a hole in the center of your axle or in the side of your axle, you can put the center or the middle in the middle. So it's good when you got that, because when you're doing like the law, you're doing the law, man, you gotta know where you started and which way you turned it.
All right, you want some power?
Hold on. Let's see here.
All right.
Oh yeah, we need to ground this bad boy.
Oh yeah.
So there's definitely a ground available. I'll use the blue one. Oh no, that's not right. That's available.
Oh, the mosquitoes got me earlier.
Mosquito?
Yeah, I was throwing disc off.
Alright, here we go. Grounded. Let's give it some power.
$10.9.
Yeah, put a little bit more power in.
I'm gonna double it.
All right.
That seems to be going faster.
Yeah. It's got a slower acceleration phase, but it's definitely working.
Yeah.
I got too used to my 16 gauge coils, man. It just poof, and it's you're there.
Yeah, that one's quick.
But this is probably going to pick up beyond what those can even do.
Oh yeah.
This is one little coil. Oh yeah. That's awesome. So we're going to have 12 of these coils on the new apparatus, which is being printed right now.
Yeah, you want to talk about this a little bit?
Yeah, it's going to alternate. There's going to be an empty space, and then there's going to be aluminum. I got aluminum plating coming that's bendable. It's like 2.2 millimeters thick, but it's thicker than foil, so hopefully it'll work the way I want it to. So there's 12 slots there. There'll be 6 aluminum plates, and then there's going to be like these things called bootrons, and they're basically 2 cones with the bases affixed to each other, or the bases are touching, and all the dimensions are the same. That's basically what it is.
Anybody have any questions about this one?
Look at that.
Wow. Yeah, that's going really fast now.
And I guess there's some spikes here that I can be catching and making it go even faster. Oh, it's moving. It's saucy. That's what it is.
Saucy.
Let's see how much torque is on that beast.
Yeah, that'll take your fingerprints off. And it kind of picks up right back up.
Somebody keeps taking my tack strips off.
Oh yeah.
Somebody like, I think his name was Vic Tor or something like that, said that congratulations, you're now with a whole 3 RPMs.
3. That's one every 20 seconds.
Yes. I said, no, you gotta be blind, man. That's 5 RPMs.
Yeah, come
It's
on.
definitely going 5.
That's one every 12 seconds, man.
I think this right here is going at least 60. It's going double.
Yeah. That old blue tag going around. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's pretty close.
But this is just 19 volts in. This is a low voltage for this machine, this toy.
Yeah, the center's spinning a
Because
lot
this
quicker.
duty cycle is definitely very high on this. It's 80%, 90%. The commutator is always touching the plate. So that the reed switch has constant power.
I think there's arcing going on here. Yeah, you can see it.
So I roughed up the plate. I took some sandpaper to it, and it worked a lot better than it was working before.
Whoops. Let me get zoomed back out. There we go.
All right. 25.
That is spinning quick. Like I can feel air. No, that might be the fan back there.
I still think it's under a certain amount, but it's only one little coil in this. I think that's awesome for what it is, man. That is pounding.
Pounding. That is, look. I don't even know if you can tell. Yeah, you can tell it's spinning.
That is an awesome trigger coil. It's like universal trigger coil. 8,000. Well, it's 4,000 bifilar coil. So it's 8,000 turns or 32 and 2 coils. So it's just awesome. And you don't have to put anything into it to get it to start.
Hey everybody, welcome to the channel.
Hey, what's up?
Let's try this.
Okay. 9 magnet rotor or 4 magnet rotor? I tried asking that on the community page.
Alright guys, about to post a poll. Send. Alright. Oh, this is wicked. Oh, and then it goes away. So we'll have to learn how to do that.
Yeah. So yeah, man, this thing is awesome. I knew it would be awesome. If we can get power to flow like this through one of these freaking things, man, that's gonna destroy the fabric of time, man.
It's gonna rip a portal into another dimension.
It's gonna raise Chris Cornell.
Yeah. He can hit a note in between a note.
Because we need his power to open that portal.
That is intense power.
So how are we gonna do that? We're gonna go back in time, ladies and gentlemen.
Mm-hmm.
Quote unquote. No, not really. We're just mainly, this is a toy. I like to play around with stuff. I'm really, really thrilled with how much we're getting out of this freaking coil. That's awesome.
What's going on, Tato?
Hey, hey. See you around, man. Thanks for stopping by. Alright. This is why I hooked up this power supply. Do 36 volts. We can blow a reed switch. That's what I mean. A transistor. That's okay.
See some arcing there.
That's good. It's warm. but it's good. This is a 9-magnet rotor too. I mean, it is whipping because, you know, if I hook up a 4-magnet rotor like this, it'd be going like way faster. Yeah, man, I'm gonna try and see if PCB Way can print my Utrons in aluminum.
Mm-hmm.
That would be spectacular because I kind of want to use solid Utrons and not wrap them. Because that would save me a lot of stress. Because have you ever tried to wrap a cone shape bobbin? That is freaky dicky, man. That's not easy. You need patience. Wow, that is moving, man. That is really moving. And that, without any extra stuff, just a transistor, and that's the only piece of circuitry we have out there. It's taking 36 volts, but no resistor or anything like that. I'm happy about that. I really am. They're not cheap, so I'm glad it's not blown out yet.
Hey everybody, welcome to the channel.
Hey, what's up? $42.6. Resistance in these coils, the little gyro right there, the resistance is great. It's 32 gauge, so we get lots of ohms, lots of resistance. Same thing, but you know, I like to reiterate.
Drop a like, hit the subscribe button.
Yeah.
Let us know if you're interested and or working with magnets yourself. Leave a comment. We are looking for people to collaborate with and or have a good time. So let us know.
Right on. Right on. Yeah, please. Oh, hell yeah, man. Cones are way better. Way better. You get a better smooth draw on a cone. I do roll my own, though. I like to roll my own, but the draw on the cone is unbeatable, man. Unbeatable.
Straight up.
Okay. All right, we got fire.
We got some smoke.
You smell that?
Oh yeah, I smell it.
That's transistor.
That just kicked it. So that is this guy.
Or is it enamel? I'm not sure. Let me feel the coil. Ooh, that is hot.
You're right. It could be.
Gotta let it cool off, man. That core in the middle must have heated up and melted the enamel. Where's the transistor that just got fried? Anyway, that is fantastic.
Wow.
Let's crack a window.
Yeah. Is anybody out there working on any projects right now?
So with 30, dang man, that was a beautiful hit though.
Yeah.
The trigger coil is king in this.
Yeah.
For sure. Wish I could get a trigger coil to work on this, but it doesn't work. Maybe it'll work. I mean, I used a big transistor instead of a small one, and it was tethered down. It wasn't a really good experiment. Alright, so, I don't know, I kind of want to turn that back on.
Gotta give it some time. Do you want to work with this one for right now?
Nope, it's not hooked up.
Okay.
I wish.
You want to do some show and tell kind of stuff till it does cool down?
Yeah, I got some coils over here that are way different. Way different. You know, I kind of want to see if this thing will move.
Oh, the aluminum rotor.
But, I mean, does it have to be AC current to do aluminum, or can it be DC?
Does anybody know if an aluminum rotor uses AC or DC current? Or both?
Yeah, that's not good. I mean, it's alright, but I mean, yeah, this is another, like, I guess it's one of my inventions. It was over here. It's a round disc, magnets on it. There it is. There it is. It's a 4-inch disc with magnets around the edge. It's falling apart. But it has that center hole. Since I work with a 1/4 inch, that works just fine. And you can center the big magnets pretty much in the center using one of these acrylic discs and some magnets.
Genius.
I'm gonna have to give it another good rundown. Getting all the glue off the table.
Oh yeah. Shot back.
Right.
The levitation before the levitation. He's going to center that toroid onto the aluminum rotor.
It's not perfect, so I mean, it's close enough to use, but when you get up to like really high speeds,
It'll wobble.
oh yeah, that's nice and smooth.
That looks good. Let's see.
How centered is it? Okay.
Yeah, I barely see any. That looks good.
It's a little off, but that's alright.
Yeah, there's a tiny one. Like, but my hands are shaking at the same rate. And there it is.
of these times, it'll be dead center, and then it'll be great for a little while. So we got to move it up closer to the rotor.
There it is. You see a little wobble.
Shoot, I forgot to get that. Yeah, that might be difficult to use some kind of magnet. How would I do that?
Clips. Clamp.
I mean, just to use a transistor and trigger it with the trigger coil. I need to,
Is there a clamp that's made out of a magnet?
maybe.
Because you just have to clamp it on there, right? Oops, sorry. I was looking at him.
Clamping a magnet on. Can't be one of these flat ones.
Oops. I'm just giving my back a rest a minute. I'll get back up in a minute.
Now we can use ferrite. But I got these little nickel ones. They're pretty good. Right here, these. Try clamping those.
Okay.
But they're gonna fly off. I mean,
That's right. Even a clamp would do that. So, yeah, I guess low.
alright, so it looks like we can do one like that.
Oh, I
That's
see
as
it.
it's gonna get though.
Yeah, I see it.
Or we could set up another one like that.
Just set up one first, because we don't need too many projectiles. And limit the power for sure.
I don't know if that's what we need to.
Okay, to get it around. All right.
Yeah, and then we go 180 with it.
Yep.
Man, this gets really messy. I hope that's enough. Get two more of those. And I got ferrite magnets.
Hey everybody, welcome to the channel.
Maybe eventually I'll learn how to do this without a transistor. I'm gonna have to definitely
Oh wow, that went on its own.
But I moved that.
Oh, you did move it?
Yeah.
Okay.
Alright. The magnets are catching the coil. And we need more. Like closer to the magnet.
Yeah, I think so.
Definitely. Maybe get a few more. I I don't know, this is all experimental for me.
Right.
I'm just gonna grab them all. I got big round ferrite magnets that we can use too.
And just put them next to each other going out towards the coils.
Yeah.
Yeah, that's great. See if I can get a good aim on that. But yeah, the bottom one.
Yeah, it's as close as it's gonna get.
Okay.
I think. 'Cause it looks like it's getting closer to the. Maybe if I put one more down here on the bottom. No, that's sticking out.
Okay. Let's see if it'll work.
Wow, it's moving on. It was moving on its own real quick there. All right. Now I gotta glue that down.
Hey everybody, welcome to the channel.
Hey, what's up? What is up?
Drop a like, subscribe, leave us a comment. We're working with an aluminum rotor and doing some experimentation.
It's probably the transistor. That's what it was.
That smell?
Yeah. So we'll swap that out real fast, and this will probably work then. There's a ferrite 2-inch ferrite core, 3/8 in diameter, in the center of this coil. It's a Bedini-style 30 gauge coil and a 26 gauge coil wrapped on top of each other. It is 999 turns, 9.9, so it's 1,000 turns basically. Yep.
Let's see if that's still on here. There it is. And that's the coil winder right here.
Sure none of those are touching each other. Alright, next one I'm hooking up in a breadboard.
Yeah.
Alright.
Is there impedance difference with the 999 as opposed to the 1111?
I'm sure it's way different. If I know what it is, I don't know what it is, but I think there's less in this coil than there are in these little coils, or 32 gauge coils. And that is not working.
Okay.
It's not, either not close enough or...
That's what I'm thinking. We're at 22.
So we'll figure out the aluminum rotor. We'll figure it out.
That was a good attempt.
There's a way to do it without magnets.
Yeah.
Huh. All right. That's a nifty little design though there with the magnets.
Mm-hmm.
Clamping them down the bottom one. We'll tuck that away for now. Because that's how the one of them printing out right now is supposed to run. Totally forgot that I glued that down. I just did it a couple seconds ago. So we know the 9 magnet rotor works.
Were those neodymium magnets?
No.
Yeah, that's aluminum, but there was a magnet underneath. Oh, excuse me, aluminium.
Who were you adhering to saying that?
The periodic table. No. No, it just wasn't obvious. I was trying to get it in an angle.
Then the cord is never long enough.
Oh, okay.
Yeah, that's going to be really close. I hope that stays. Yeah, there's a jerk on the pole with that. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is a good measure. Right. This. Boom. Right. So, I mean, if we can get some more ideas about the aluminum rotor, I'll whip it back out.
Yeah, anybody have any ideas on how to get that to spin without magnets? Yep, there it was. You were right on that.
Same thing.
Mm.
It's all right.
Use a 5 horse mower engine on it.
Get some gasoline up in here.
That's some diesel.
Yeah, I'm having bad luck with glue right now.
Your glue skills are usually immaculate.
Yeah, I know, but this glue sucks.
Oh, we got a bad batch.
Something's not right with it. It's not setting like it usually does. And then, whatever.
It's definitely not as humid out.
Alright, so in the next one, these coils will be upright like this, with the north side at the top and the south side at the bottom. And they're gonna have contact cores that are gonna touch aluminum plates and the ootrons
Ooh.
in a gyroscope fashion. The ootrons are gonna be hooked up on bearings, so they're gonna be able to spin relatively fast. I just need to know what type of current and how to do it. If I can get that aluminum rotor to spin, that's going to open up a whole other can of worms.
What's up, Acid Rocker?
What's up, man?
He asked, what is going on?
This, and we're testing out a Bedini-style Bifilar coil with a ferrite core. Just a little tiny thing I'm going to use for a gyroscope. I'm going to bust out with 12 of these bad boys. Let's check it out. Oh, something's not right. I think that... something must be touching. Of course, look at this freaking mess.
Mm-hmm.
I know there's people out there that are probably cringing right now. Alright, that seems to be good. That looks good too. Let's give it another go. It's alright, man. There's wires touching wires here for sure. I'm about ready to clean up in front of everybody.
Oh, we're about to clean. I hear you. I hear that.
I don't know. Dang, I said I would behave.
Maybe a hamster. A dwarf hamster?
But I'm joking. we're going to untangle all these wires so that we have a clear idea of what's going on here. And now I have magnets wrapped up now.
Hey everybody, welcome to the channel.
Hey, what's up?
Drop a like, subscribe, leave us a comment, let us know what you're thinking. We're trying to get this pulse motor to work right now. And if you guys want to support the channel, we have memberships available through YouTube. And we can get you a free 3D print if you go for the master's level.
Yeah, master's level. All right.
And everything here is 3D printed. So we are working with our own devices.
Power in.
Oh, just naked?
Well, that's power in. And this. Here. The Bedini diode thing where you put the AC refractor back into DC and then shove it into the 26 gauge coil. So that's that. That's hooked up. Now this is hooked up. This needs to be, you know what? Right here. I'm gonna use one of these big boys right here. Alright.
I'm trying to get a good angle.
Well, that's going to be done printing. It's 93% done.
Nice. That picked up quickly.
Score. And it's not going to pick up quickly because it's a Bedini coil, but it will pick up more speed than, say, a single file coil. But it'll just do it a little bit slower.
Welcome to the channel. Thanks for dropping in.
Hey. No, it's not a well, it's based off of that, yes. Based off of a UFO time-traveling machine, yes. But it's not. It's just a toy.
That's fine. One minute. Oh, how much powder we got going on? Oh, 21. All right. Let me get in the shot. There's the cameraman.
Hey, what's up? Yo.
I'm good.
So yeah, that's good. That is great speed on this 9-magnet rotor. What's up, son?
Hi.
You helping out?
Yeah, I'm the timberman.
Good, good. Hey, high five.
Rock on.
I love StarCraft, man. Oh, that's StarCraft? What's StarCraft?
No, that was there.
My bad, Mike.
Maybe not. That might be something different.
No, I think it's StarCraft.
Okay.
But I guess you can't put it in there.
Ooh, I stationary camera.
Pretty much. I guess you have like a gyroscope in the Gatling gun that perpetuates its motion, makes it spin faster.
Ooh, palladium or titanium to magnesium. Okay, thank you. You're getting some good camera action.
Yeah, I'm definitely not going to use magnets in the OCT or OTC. I'm not using magnets in that.
But let's see. Palladium, titanium to magnesium. Nice. It's a good point though with the heat.
So you're talking for windings too?
And welcome to the channel, Zach's Lifestyle.
Yeah.
Let's look at it again. Is it possible to combine it? Palladium and magnesium, or titanium and magnesium?
Well, if we look at it from like a Lord of the Rings perspective,
Like an alloy.
you want to mix mithril with gold,
Mm.
you got to mix it a certain way. You can't like force it to happen. You got to like mix it together.
Coax it.
Yeah.
I wonder if there's a different way. But that's a good question. I don't think we've thought on those lines before.
Not really. I haven't even thought about it yet, but that makes sense that you could probably combine any material as long as you know how to do it.
Yeah, those I don't know. 2 magnesium. That would be great.
And that's what I've been trying to figure out about this aluminum rotor. How do I get it to spin without magnets? How do I do that?
And then are there going to be magnets without any rare earths in them?
No, you're probably not using the wrong terminology,
Yeah.
Zach. That's awesome. That is awesome, man. That coil is bad. It's really bad. Very good, I mean, very good. I got these single file 26 gauge coils, same size, but they don't have the 30 gauge coil in with it. Oh no, they're not, actually. These are 1100 and 1101 turns of 26 gauge. See, look at how that rotor in the middle is still spinning pretty well.
Do you think if I could theoretically put them together?
Yeah. Minecraft. Villager. Do you think if I could theoretically put them together, I think the direction is in the way that you put it together. But yeah, I think it would be a great conductor of energy.
Yeah, the way I think about it is like when you have like molten rock,
Right.
and then it cools off, but all the filings that are in it point to due north. So there's a mechanism at play here.
Let's make a magnet.
Right, but then I start to extrapolate that piece, like maybe
We're
there's
talking about making magnets, right?
exactly. So maybe there's a way to combine materials so that it would do that.
Well, there's this material on the periodic table that starts with an X. It's very low on the periodic table. Down here, it's got a high number on it for a material that's safe to use, and it's very magnetic. It is extremely magnetic, and I'm sure that it takes a lot to melt it. But it starts with an X.
Okay, let's see. Attraction and the drop, the magnetism as it reaches the point. Yeah, have you, well, yeah, we don't. Huh. Yeah, hit us up on X and we can collaborate on that. You can find that in the about part of the
Yeah, we can get
channel
our
page.
hands on some badass magnets. I'd love to do that.
Mhm.
And I've been trying to get away from rare earths, but they're the best right now. For me, anyway, I haven't been able to find any industrial strength magnets that I haven't been able to find them. So, I mean,
But yeah, if you're able to create these magnets in a reactor, I'm assuming the composition has to be in a certain way for that to work.
I mean polarized.
Yeah, and like the differences between the elements would create.
An increase in power.
Yeah.
And those, and the higher the temp to melt it is important too. So. Awesome.
Sounds good.
I'm interested, very interested.
Nice to meet you, Zach.
%97%. This is the first iteration. I might have to redo this.
That's for the bigger one of these.
Yeah.
Yeah.
Because I think I'm going to have to make this wall a little smaller. A little shorter.
Yeah.
Leave the rest of it the way it is, just make that outer ring a little bit shorter. So the neutrons can fit in there and spin normally. But it's just, the thing is, I've seen it when you put a neutron in a Dremel and you spin it, it'll make a magnet spin, but that's not what we're trying to do. We're trying to get we're trying to get an electromagnet to spin a neutron. That's what we're trying to do. And there's going to be a bunch of gyro going on in this thing, man. Like gyro on gyro on gyro on gyro. It's going to be like a gyro fest.
Mm-hmm.
Sorry, that was really immature, but that's what I feel about it. Gyro. Little Utron gyros.
Yes, the Utron. Oh, we just got the battery power warning.
Oh, really?
Let me see. I'll stand here. Let's see how long we can get.
pretty cool right now, but remember I felt it that one time and it was cool, and then it just felt when the transistor blew.
Yeah.
But can you imagine like 12 of these things in series?
Wow.
Or maybe I don't need 12. Maybe I only need 6. Maybe it's just the 12 slots on the rotor that you need because you need 6 neutrons and 6 aluminum plates. That's 12. And then you need however many coils you need on the end, on the gyro. But of course, I mean, like if this was going to be a spacecraft, it would be legit hooked up with wireless electricity and everything that it needed to go forever and never come back. And it would have all that stuff with it. Just obviously, it's lacking a few things.
Like some seats.
Yeah. Looks like looks like something you would put on somebody's seat for a practical joke.
Yeah.
Yeah, that was funny. Oh man. Okay, so there's not much more I want to try out right now. I mean, I do want to make a 4-magnet rotor that's smaller than this one. Oh, I already have one.
He said, if, come on, I don't have a lot of years left.
Yeah, don't worry about it. I already did this.
Welcome to the channel, Pfefferminzent.
Hey, hey.
And he says, what does this machine do? And it's an Anga Boinga. Anga Boinga.
This machine right here, it spins in both directions at the same time. It looks really cool on a table. And that's it, man. It's a toy. That is a toy. That's series circuit. That's 6 coils hooked up in a series circuit with 1 reed switch and a 95% duty cycle. And commutator of 24 gauge wire.
I'll zoom in on that. You can see some. You can usually find some arcing happening. There's a little bit. Yeah, right there.
I gotta readjust that commutator strand. It's getting a little close to the middle. It's gonna kind of be on to the outside of it, or in the middle of it, instead of being an inner edge. That's what I meant to say.
Welcome to the channel. Germany in the house.
Alright. That's awesome. Gotta be really delicate with this thing or it's gonna like come above the... Alright, let's give it a little juice.
Hey everybody, welcome to the channel. Drop a like, subscribe, leave us a comment if you're interested in pulse motors, gyroscopes, magnets, coils.
Oh yeah. Oh yeah, I was gonna show you guys some coils. I got all hooked on that.
Oh yeah, here we go.
This one right here is a 26 gauge, or is it, no, it's 24 gauge, 4-filer coil. It has 200 turns per strand. That's 800 turns of 24 gauge. This little thing is a beast. especially if you hook it up in series with itself. It's pretty nasty.
Hold on 1 second. Pfeiffer asked if we have a 3D printer running in the background.
Here we go. So, I actually had a whole series of these 24 gauge drive coils.
Excuse me.
They work pretty well, actually. 800 turns altogether with 24 gauge. Here, this is
We're printing a scaled up version of this one.
yeah. This is a 10 file coil.
Look at that.
So you got 24, 26,
Zoom in.
and 30 gauge in this coil. It's a heaping mess, but they're all marked. If you separate them good enough, it's a good coil. So it's got one of these inside of it, and it's got one of these made out of 26 inside of it, and then it's got two 30 gauge strands, and 200 a pop. So there's 2,000 turns each one of the 10 file
Careful.
coils. Uh-oh.
Welcome to the channel. The Glidra.
Oh, we
Brazil is in the house. What's
Hey,
up, Brazil?
Hey, you can check this out. It looks like I guess a Tesla turbine, right? It works with air better than it works with water, though, or liquid. You know what I'm gonna do?
Thank you. Excuse me. Thank you, Glira. Oops, sorry.
And don't, yeah, right here. Here we go. We're just gonna put. Look at the flywheel capabilities of this little rotor here. Oh, the printer's done.
Ooh, it finished.
I need.
Space.
No, it's like well, yeah, but I need one more bearing.
There's two of them here.
Do they have? They gotta be this size.
Okay. Nope.
I just need one more. I can put it in there.
Yep.
Okay. Perfect.
We are from Detroit, Michigan.
So that's gonna be a really loose fit, but it's good. Good fit. For this project anyway.
Are you gonna grab the shop vac?
Yes indeed.
Okay.
I'm gonna put 2 horsepower into this beast. Oh man. Let's get the aluminum. No, this is what we're gonna do. We're gonna make a makeshift table. Flat surface. Vacuums.
Hey everybody, welcome to the channel. If you have any questions about anything we're doing here, let us know. We are working with pulse motors, 3D printers, electromagnetism, experimentation, and we're about to test this turbine out.
See, I got those spacers in there, and it makes them so they can just slide in and out, basically.
What's up, Jay? This right here is an experiment. Those are 3D printed arms inside of acrylic discs. Let me go zoom in on it. Now, I didn't do anything like that, BLS, but definitely lived on 9 Mile as a kid. Caleb, what do you think of that? We actually did not come into this with any technical knowledge. We've learned from the community, and you know, he's looked up some things on his own, but he does not have a degree or any background in this. He's done it all, learning in real time and community-based learning. It's pretty cool.
I'm sure that works.
Nice. Yeah, it was probably 20 years after that. 21 years after that, we moved away from there. Moved out to this area we are now. Oh yeah, I can't wait to see that one. The wheel.
Yeah, that'll be awesome.
All right, so this is supposed to be a wind. I mean, wind and
What did you say
or
to me?
viscous liquid in here,
Don't say
because
that.
if we have
What, this?
liquid coming in through these and then coming out the holes that are in the
Why?
center. So we haven't been able to test it with a liquid loop yet,
It's because it's off.
but we're definitely putting air inside of it now,
Oh, that's not good.
and all
You
hand
need to
done
tell
by
me when
hand.
stuff like that
So-
happens, okay? All right, here we go.
No, not anymore. Don't, he'll hurt you. Wow.
Oh, see that?
Yeah.
That's it right there. That's where the money's at. Gotta get a windy, really windy day.
I'll put in a plug for Detroit. You know, we've lived here our whole lives. Definitely after the bankruptcy, they've definitely cleaned up the downtown. A lot of the blight in the residential neighborhoods has been bulldozed, and those areas have turned into urban farming and urban gardens. It's beautiful.
Here we go.
An entire blocks got turned into these things.
You hear that still revving up?
Yeah.
It's moving on that side.
Oh,
Yeah.
there's. Can you feel air?
I can feel it. Just barely though. It's like little wisps of air.
All right, let me read that.
This thing needs air to work.
Yeah, good deal. Joyriding.
And there's holes in the middle of this that the air's supposed to like come and be like just flow out through the middle,
There's the holes.
so that you don't get the backlash from the air coming back up through the things. You know, and I think it works. It looks like it was working then.
And then there's 4 acrylic discs and 3 of the 3D printed shapes like that.
Yeah, those bearings are just kind of sliding right out of there.
And check if you scratch you.
No, we didn't scratch.
Okay, I got some.
He was just going, please.
That is
He was
beautiful.
scared
This
to
is
thank
beautiful,
you.
man. I love this thing. It's the only rotor that I have right now that spins on the shaft. The shaft spins. It's part of the shaft spins, so it's awesome. I'm gonna actually hook something that I want to generate electricity on either side of this. You get what I'm saying? So here, pass me that rotor that's right next to you. Thank you. Let's see if I'm being overzealous or not. Now, let me get... Whoa! It probably won't spin, but until we get them on there.
That's right, and even the old Devil's Night, the night before Halloween, is now Angel's Night. So community members just walk around making sure nobody's causing mischief.
Man, did you just watch that happen?
No, I'm watching this.
Okay. How was that?
I think it's
It's behind you. It's probably that wood.
this.
Yeah. Weird.
That was weird. This is a 2-person job.
Hell yeah. Damn. Alright. Okay.
All right, now I'm gonna.
No, I mean, technically, this isn't going to spin it, right? But we could do something like this and have this spin both of these.
Yeah. Yep.
And we could generate, you know, like this on the bottom, and then on, if we have it out far enough, we could generate on both sides of this, because you got north and south on either side. Oh, that's awesome. So I'll have to piece all this together again. But that's all right.
I'm gonna try and stand up. Hey everybody, welcome to the channel. Thanks for dropping in this evening. Let me get myself untangled. We are working with pulse motors this evening, and Oh, look at this one, bro.
He's the calmest boy ever. He didn't sing.
Yeah, I know. And then reuse the air basically
Oh,
over
that's
and
what.
over again.
And you were talking
Yeah.
that for the hydraulic loop too.
Yeah, for the viscous liquid
Mm-hmm.
turbine that Tesla did. He kept on burning the copper plates up at around 20,000 RPMs. He never got it to function because it would always melt.
Maybe that's what Zach was talking about.
Yeah, don't put so much pressure on that, dude.
Oh yeah, it'll. So just grab it from top and bottom at the same time. You got it.
See how it's... Oh, we're going to have to redo that now, too.
Oh, from the base.
Yeah, it's like it's wobbling. But you go ahead and play with it until we fix it, and don't play with it after that.
There we go.
That is an awesome wheel, though. It's made out of steel. It's magnetic.
Don't wet hands. Got white stuff.
You got the white stuff on your hand.
All right. Boom. I love this thing.
This is fun.
See, and then with that enclosed method that you have, I also have a hollow shaft that I would force the air through as a part of the design. Instead of using a rod, I'd use a tube.
Oh, and then it'd come in through the center.
And then you could channel the air through the tube and then up back into the channel.
It's the whole system.
Yeah.
What size wheel is that?
Hey man, you did it again. Go wash your hands again.
Oh, you got the yeah, I can see it. I can see where it is. What size wheel is that?
20 inches, I think.
Was it 26?
No, wait, maybe it is 26.
You'll have to look at the receipt on that one.
Mm-hmm.
Okay.
It's been like a year since I played with it.
Right. Oh, I don't see a ruler. But yeah, 26. Yeah.
Yeah. 44 spokes.
Oh. Well.
That's one way to get it done.
That's right.
And then just throw it across the room for good measure. Like, ha. Just don't break any glass, because you like walking around barefoot, so don't do that. Oh yeah, yep. The lube, the nut is loose, so I gotta make the nut strong again. That's not supposed to happen.
Okay.
Where did that bearing go? Did you pick up a bearing, Bill?
You put 2 in.
No, it's a different size bearing.
Oh, that.
We'll find it.
That one?
No. Looks like this one. Silver around the edge. And it's a flange. So it just fits right in.
Pfefferminson said, and if you channel the air through some sort of slit aimed at the turbine, you could get even higher torque in RPM. So that's kind of what you were saying with the
Yeah.
shaft thing. Yeah.
Nope. None of them are spinnable right now. This one is.
So I got
Mm-hmm.
I got about 25 minutes left in me.
Okay. Alright, now I'm going to turn it on, so don't touch it.
And I can set up the tripod if you want me to.
I don't know, we'll see.
Okay.
Let's see, I'm running out of... Oh, I do want to take a look at this.
That's going fast.
So like every other one will be covered in aluminum on the sheet that'll be cut nice and then bent over and cut nice on the up.
Yeah.
Thanks, BLS. Thank you. Alright. So that's coming in the mail pretty soon. Aluminum plate. It's like this copper plate right here.
Have a good night, BLS. We'll see you soon.
See, so this one is designed not to house any magnets. See, there's no magnets for this one. I might have to make it like an inner ring for the two Turons, I think they're called.
Okay.
The Neutron.
Hmm.
It's like some sort of, there's two like puzzle pieces that go together that make it the perfect angle to fit.
Okay.
Like they go together or something.
I think angles have a tremendous amount to do with frequency.
Me too.
Mm-hmm.
This is Hyper PLA. And that's Ender version 3, Ender 3 version 3. I like using the Wi-Fi printer capabilities.
And we have some retired machines about.
This is, I knew this was going to happen and I'm so happy. So happy with that. 'Cause that's really a teeny coil. It's very small. There are smaller coils, but I mean, it's only 1,000, well, 2,000 turns, but altogether. So maybe it's a beefy coil in a small package. Right?
Mm-hmm. Yeah, the sound of the wires across the commutator. How do you control the frequency in the coil?
That's a good question.
Right. So we know about inductance. We don't really know the formulas.
I'm pretty sure frequency is the speed in which a reaction occurs. So, usually it's measured in hertz or gigahertz or megahertz, and we usually have about 112 hertz or 120 hertz in the pulse motors, which is nothing in frequency talk. It's like very small. So me, I would consider controlling the frequency of a coil by increasing or decreasing the voltage, or increasing and decreasing the resistance. Now coils have natural resistance. So if you're going to run with a 32 gauge coil, you're going to have to put in less resistance to get to where you're going. Because it's already there. You already have ohms in your coil already. So all this together, I'm not sure if frequency is measured in a coil necessarily. It's either measured by your generator, your signal generator has control of it, or your motor. You can measure the coil on your motor, but a coil just sitting there has no frequency. Like, well, that's not true. That's not true. There's static, and that's what we're doing with this rotor right here, man. We're exercising the static field. So I know, like, senders and receivers of wireless electricity are stagnant coils. They're still, but they work. But I'm pretty sure there's a pulse generator somewhere sending the frequency through that coil. You know, it's being applied to the coil. It doesn't come from the coil. That's just my understanding. But like, yeah, like I'm saying, you turn the remote on to power the remote control car, then all that stuff starts to work. But you have to turn it on first or it won't work.
Oh, there's a personal one.
What do I do for a living? Oh man. Well, I used to be a greeter at Meyer.
He's a full-time stay-at-home dad.
Yeah, I stay at home.
There's,
But I got to go out there and get another job. I don't have a career. I mean, I do this for fun, and I would hate to make this my job because then it wouldn't be fun anymore.
that's a good point, bro.
But, you know, maybe, I don't know. I don't know. I'd have to get an education if I wanted to make this my job. That is for sure. Beyond YouTube education.
Yeah. I mean, you'd be surprised at what people like collaborating and teaching themselves.
I love collaboration. I love teaching myself. But I don't know. I felt like what I was just talking about, and those two things are different.
True that. I hear what you're saying. Because I think you'll succeed here just doing what you're doing, bro. For sure.
Yeah, I did manage to get enough traction to be able to start memberships. So if you would like to join up, $2.99 for a student membership. That's the one I have. You'll get access to our Discord, and we can chat after live streams, vocally, verbally. We can chat and talk about stuff. I do want everybody to try to bring it down when we're communicating to a level that is understandable for everybody. I'm talking about myself in particular. I'm trying to learn here, and it's like there's a lingo out there. It's like spitfire talk about this stuff, and I don't understand it at all. I don't get it at all. It's like, wow, man, what are you trying to say? Where do I connect this? What do I do now?
It's like Jimi Hendrix teaching himself how to play the guitar.
Awesome. Thank you.
Thank you, Five for a minute cent. Appreciate the super chat.
Really appreciate that. Nice. And because I'm just shooting a breeze. I like to keep moving, so I have an idea. I'll roll with it. But if somebody has a better idea that they'd like to share, get so we can chat. And then I will look over all the ideas in the chat for live streams. I'll look at all that stuff, and I'll implement as we go. Yeah, here we go, Peter. I got cool emojis. I got a rotor on there that looks kind of like a butthole. 4 magnet rotor looks kind of like a butthole. You could just You can say, "Hey, man."
Drop the emoji. Yeah. I feel like you gotta work on that one, man.
It's
No.
awesome. It's awesome. It's great. I tell you what, man. And there's two pictures of me. One smooth and one is look. And then there's two rotors. One is the butthole rotor, which is right over there, actually, underneath the box. Because I got all the lines drawn in there for the degrees. So yeah, kind of just.
Oh yeah, I remember that
Looks
before
like it,
before it
you know.
turned into an art canvas. Yeah.
I had everything. Hey man, I'm just being serious. I wanted to be the first one to say it before somebody else said it to me or recorded before. It's a rotor, no doubt. Just look real close. It's a rotor.
The aluminum part.
The Utron you're talking about, or the rotor?
Where did that go?
This? This is I bought this off of Amazon. It is
Oh, he's talking about the aluminum parts that are coming for the 3D print.
they're in a roll of aluminum plate that is about this thick, 0.2 millimeters thick. So I'll be able to bend it around.
And we got lots of random machined aluminum.
Yeah, like this right here is how thick I wanted it to be, but I can't bend that. I don't have a machine to bend that.
Mm-hmm.
It's like an eighth of an inch thick. I can't bend it. This here's a 1/4 inch. Excuse me. Whew. So I have a serious question. Do I use bearings in a 1/4 inch shaft? Or do I use a 1/2 inch shaft and use the shaft as a rotor?
Is this that one?
Yeah, yeah.
Yeah, you can see the difference there.
But
So
if I
this is the
shove,
shaft.
yeah, if I shove that in here, I'll have to spin the shaft to make it work.
Yeah, so spin on the shaft. Oh yeah, the shaft has to spin. Got it. So a motor.
No, I could just set it up the same way.
Okay.
But I'd have to have, these are the bearings that I would have to have in like the base. I'd have to make it so it could spin freely, the shaft. So there'd have to be bearings in the base plate. I'm not planning on having this thing fly away.
Right.
And if it's going to try and fly away, I'm going to have a cap on this thing so it's tethered down.
Yeah. Search through our videos for catastrophic failure.
Yeah, for real. Oh yeah, man. I think this would be great. Maybe not this particular one, but something like this, for sure. Maybe a combination of, because we're supposed to have a big clump of aluminum in the middle of this thing. A big Utron that's upright in the middle. So, there's a chance we could put some of this stuff together. And there's no magnets that'll work with this. I'm trying not to use magnets.
Yeah, we're gonna go magnetless on this one.
Now I've seen it on YouTube. A guy that had a coil underneath an aluminum rotor and it spun. Not very fast, but it spun. How did he do that? What was he using to make that happen? Is it straight DC current or AC current? Is it just AC current because it fluctuates like this? Does that work? And if it is AC current, how do we get AC current on just one coil? Oh, I think I know. I think I just had an epiphany. We're going to take the diode out and it's going to be AC. But now that it's AC, does it need to pulse? That's my standard understanding of what makes a motor move is the actual pulse. Let's give it a shot. It needs to be closer. Go ahead.
How up to what?
25.
All right.
No, I think the transistor and all that stuff being hooked up too is not. It's not going to happen this way. I needed a rect, and this is a DC power supply, so. I got an idea. Just real quick, could you turn that down? Thank you. Thank you.
Down.
We're just going to remove the emitter, and we're going to change it up with the collector. All right, turn it on. Let's see what we get. Whoa.
24.
Look at it go, man. Or it was going.
Oh, it's going the other way.
And it's repelling the magnets.
Yeah, Peter posted a link.
Okay, we'll check it out.
Nice to meet you, Pfeffer. Thank you so much for the super chat.
Thank you so much.
Have a great evening. Germany in the house.
Yeah. We'll figure it out. Alright, cut the power, please.
Yep.
Yeah, it's getting hot.
Down.
Yeah, I guess just having the coil on like that
Yeah,
makes it really hot.
right in his palm. Yeah.
Oh man. Alright. So I'm gonna have to consolidate cap and coil in parallel to make it work.
And he posted a link right there.
Is it a super cap? Or is it a regular DC cap?
Has to be AC cat, small ceramic.
I don't have any ceramic caps, dude.
All
I
right.
got electrolyte cap. But this is 275 volt AC.
Zoom in on it.
I got this, and then I got four start caps that are AC. They're 100 volts. Yeah. And I like these ends for this too. These ends have you can clip some stuff on here.
Give it a shot.
Alright, so where do I put this?
Mm.
Oh,
Did
it's
you-
on the video.
You may have already said that. Yeah, what you need is on the video. Cap and coil in parallel. The cap in parallel with the coil should get it to oscillate.
But it's a Bedini coil. It's 2 strands. Parallel with the whole thing, right? So
Not in series. Yeah, the whole thing.
okay. This and then like this, right? So you clip it to both ends. Either end, like so. No, is that series? I don't know. Is that series or parallel? I have no idea at this
Oh.
point.
The
Well, you should come over here and look at it.
what am I thinking about? The
Over here, bud.
I'm tethered.
Don't step on it. It's 15 feet long. I sit in the chair with that thing.
Oh, I was stepping on it. Sorry, guys.
So here's the end. Here's the beginning.
You said that's parallel.
Okay. Sweet. Let's turn it on. Wait a minute. Which way do we want it? Do we want it underneath or facing towards the rotor like that? Let's turn it on. Let's try it. Oh, it's hot.
19. You said the face.
Hmm?
You said the face.
Oh, the face. So, like, underneath it, right? Just having it on.
The top. not the skinny sides.
Like this. Like this.
Give it a spin.
This should be doing like eddy currents, right? Something like that.
I wonder if you just try to move it around and find a spot. Turn your coil.
No, there's too much wire. Alright. Yeah, there's too much.
Turn your coil just 90. Something like that. Yep, he's like that.
The wire, though. Wires are getting in the way.
I thought I saw a sweet spot.
Don't. You should. Yeah, go ahead, go ahead.
Spark gap? Question mark.
Well, I can't just hold it in the right spot. That isn't going to happen.
Okay, maybe it needs a spark gap.
Spark gap is a gap. Right? But what's a spark gap?
Yeah, that was moving. Maybe it was your...
It's the coil is being attracted to the magnet. You got to turn it on the... Wait a minute. Power's on.
Yeah.
Oh, I've turned it upside down now, so now it's attracted to the magnet, but when we turn it this way, see now there's too much fucking wire everywhere. This little thing is getting hot.
Here, I'll turn this down. Nice. All right.
So we figured something out. There's a north and a south pole of the magnet. Yeah, but we knew that already.
All right. I'm going to turn this on. I'm going to turn it to 20.
Right, and watch what happens to... Nothing's going to happen to the magnet until we turn it over. Wow.
Hot.
No, it didn't, it stuck to it again.
It's like moving right before it hits it.
It's because I'm touching it.
Oh, you're touching with your hand. My bad.
Yeah, there's definitely some funky pulling going on there. But it's getting, you can turn it down.
Okay. Welcome to the channel, everybody.
Yeah, I heard about the spark gap when I was reading about the OTC, but I don't understand that. It didn't really explain it too much from what I read.
All right, man. I'm getting pretty good. So
Yep. I'm just
next
gonna-
experiment.
Last experiment.
Yeah.
Now, if I round up, I have another wind of 16 gauge coil available. Now, if I wind another coil of 16 gauge and try this, do you think it'll work?
Axial flux.
No. I was just seeing basically if I can prove this, then I can prove the other thing, and I can even continue with the other thing, because if I'm not going to be able to move aluminum, there's no point.
That's a good point, bro.
This is why I ask people for help, man, because if there's not going to be any point for me doing it, then I'm not going to bother. But this, I don't know. I think there's something missing in this coil that'll make it work. Uh, so, serious question. How about my next gyroscope? Do we use the shaft and use a commutator on the shaft? It'll be a 1/2 inch shaft. Or do we get 1/2 inch bearings and have a 1/4 inch shaft, and then just have it spin the way all of my normal rotors do on the shaft? Or are we going to have the shaft spin itself? What are we doing? That's an important question, shouldn't be ignored. Really important. It's like the whole foundation of the entire thing is what I'm talking about right now. And I'll do either one, but we should try and figure that out before I get started. I'm just happy I got this thing to work. This gyroscope. All the pieces came together and it functions. It's a power hog though.
Yeah, the battery's dying.
Alright. Well, thank you very much, ladies and gentlemen. Apparently my camera is about to die. So
Any last questions or comments?
thank you.
Well, thank you all very, very much for coming down this evening. We had some pretty cool experiments. You guys can check out this live on our channel. Thank everybody for their comments and participation.
Thank you.
And we enjoy learning from you guys. And lots of countries came in on the channel tonight.
Always.
Let's do this.
Always learning. Yeah, but I gotta get this to spin before I even attempt something like what I was talking about. This has to happen first.
So we are planning lives for every other night right now. But you know, if there's something critical like spinning this aluminum, we'll check out that video, Peter. Then we might have a live, you know, couple nights in a row. We'll check. We'll figure it out.
Aluminum, yeah, the aluminum disc is just a test. I keep reading the last post there.
All right. So like, subscribe. Always feel free to drop us a comment on any video. and consider contributing to the channel with membership.
Very much so.
And
Peace out.
let us know if you have any questions, guys.
Have a great night. Bye now.